Welcome to This Explainer. Today, we're setting our sights on a dusty, freezing desert world with a whisper-thin atmosphere that happens to be sitting right next door in our cosmic neighborhood. We are, of course, talking about Mars. We're going to take a deep dive right into the dynamic and extreme surface of the red planet, pulling straight from NASA's wealth of planetary science. Mars is one of the most explored bodies in our solar system, and as we go through this, you're going to see exactly why it completely captivates our imagination.
But hey, before we go anywhere, check out this wild paradox to hook your mind around. Earth is covered in oceans, right? But Mars is completely dry today. So even though Mars is only half the diameter of Earth, it actually has nearly the exact same amount of dry land area for us to explore. I mean, that is an enormous amount of planetary real estate just waiting to be understood. Okay, let's dive into this with a quick roadmap. We'll be hitting 1. Meet the red planet, 2. A landscape of extremes, 3. The story of Martian water, 4. Atmosphere and weather, 5. Moons and magnetics, and 6. Future exploration. Let's get started.
Section 1, Meet the Red Planet.
So we call it the red planet because, well, the iron minerals in the dirt are literally rusting. It gives it that blood-like hue that actually inspired the ancient Romans to name it after their god of war. To really picture its size, look at this scale. Mars has a radius of about 2,100 miles. If Earth were a standard nickel, Mars would be just about the size of a small raspberry. Kind of cute, right? But it's sitting out there at an average distance of 142 million miles from the sun, which means it takes sunlight about 13 minutes to travel out and warm that little raspberry.
Now, take a look at this comparison. It's surprisingly familiar for an alien world. An Earth day is 23.9 hours, and a Martian day, which scientists call a sol, is 24.6 hours. They are practically identical. And look at the axial tilt. 25 degrees for Mars compared to our 23.4. That means Mars actually has distinct seasons, just like us. However, because Mars has this elliptical, egg-shaped orbit and takes way longer to go around the sun, those seasons are much longer and vary wildly. Spring in the northern hemisphere lasts a staggering 194 sols. Section 2, a landscape of extremes. So while the day length and seasons might feel kind of familiar, the surface itself, completely alien. 25 miles, or if you prefer, over 132,000 feet. That's not a distance across the ground, folks. That is straight up. We're talking about the height of Olympus Mons, the absolute largest volcano in the entire solar system.
To really put that into perspective, Olympus Mons completely dwarfs Mount Everest. It is nearly 3 times the height of Everest from base to summit, and its base, it covers an area roughly the size of the entire state of Arizona. It's a geological monument that is just simply staggering.
But Mars doesn't just build high, it cuts deep. 2,400 miles. That is the massive length of a vast canyon system on Mars called Valles Marineris.
And this brilliantly illustrates just how massive it is. Valles Marineris stretches 2,400 miles long, spans 370 miles across at its widest, and plunges almost 6 miles deep. It's literally more than 10 times longer and wider than our Grand Canyon. If you drop Valles Marineris onto the United States, it would stretch all the way from California to New York. Absolutely wild.
Section 3, the story of Martian water.
Seeing all these massive, dusty canyons and volcanoes, it's so easy to picture Mars as this permanently dead, rusted rock. But that pegs the biggest question that's driven decades of space exploration. Was Mars always a dry desert? The answer? Unequivocally no. NASA missions have found overwhelming evidence that billions of years ago, this planet was much wetter, warmer, and had a vastly thicker atmosphere. The evidence is written right into the rocks. Rovers and orbiters have mapped out ancient river valley networks, extinct deltas and lake beds. They found miners on the surface that literally only form when liquid water is present. There are even geological scars pointing to massive cataclysmic floods that ripped across the landscape about 3.5 billion years ago. And get this, the water isn't totally gone either. The atmosphere is just too thin for liquid water to last on the surface today. Instead, it's hiding as ice just under the polar regions, and sometimes salty, briny water actually flows down hillsides and crater walls as the seasons change.
Section 4, Atmosphere and Extreme Weather.
If you were standing there today, that hazy red sky would be incredibly thin, mostly carbon dioxide, nitrogen, and argon.
so it offers pretty much zero protection from meteorites or comets. And because the atmosphere lacks density, the sun's heat just escapes right back out into space. You get these wild temperature swings from a comfortable 70 degrees Fahrenheit all the way down to a bone-chilling -225 degrees. Oh, and the weather? High winds can kick up global dust storms that literally blanket the entire planet, taking months for the dust to finally settle back down.
To really grasp how poorly this atmosphere holds heat, just imagine this scenario. If you stood on the surface of Mars at the equator right at high noon, the temperature difference is so crazy that it would feel like spring at your feet, around 75 degrees, but freezing winter at your head, like 32 degrees Fahrenheit, all within a 6-foot height difference. How crazy is that?
Section 5. Moons and Magnetic Mysteries. While Mars has no global magnetic field to date to shield it from space weather, ancient magnetized crust tells us that 4 billion years ago, it definitely had one. Looking higher up into orbit, we find Mars's two small moons, Phobos and Deimos, named after the mythical horses that pulled the Greek god of war's chariot. Now, these aren't perfectly round moons like ours, they're likely captured asteroids. They just don't have enough mass for their gravity to pull them into spheres, so they end up looking like giant space potatoes. Phobos, the inner one, is deeply grooved and cratered. Deimos is smaller, much farther away, and oddly covered in loose dirt that smooths out its craters.
Let's move to and see how this builds, because it's pretty spectacular. Right now, Mars doesn't have rings like Saturn. But the innermost moon, Phobos, is slowly spiraling closer and closer to Mars. In about 50 million years, it's either going to crash directly into the planet, or gravity will completely rip it apart. Either way, it's eventually going to create this beautiful, dusty ring entirely encircling the red planet.
Section 6. Future of Mars Exploration.
We know so much about Mars's past because of our relentless drive to explore it right now. Our understanding of Mars is a real-time, active endeavor. Take NASA's ESCAPADE mission, for example. Launched back on November 13th, these twin, refrigerator-sized orbiters are cruising through space as we speak. They're scheduled to arrive in September 2027, with science operations kicking off the following spring. Their main goal? To study Mars's real-time response to solar wind, helping us untangle exactly how its climate transformed from a haven of rivers and lakes into the cold, dry desert we see today. Which leaves us with this final, profound thought to ponder. Right now, as we speak, Mars holds a very unique distinction in the cosmos. It's the only planet we know of inhabited entirely by robots. Rovers, landers, orbiters, there are mechanical eyes and ears on an alien, yet strangely familiar world. As new missions arrive and we keep untangling its ancient mysteries, we have to ask, what is the next chapter in our relationship with this robotic outpost? Will the rust and dust eventually give way to human footprints? Well, that's something to think about until next time. Keep exploring, keep questioning, and thank you for joining me for this explainer.